Okay, so in this video we're going to be reviewing fluid kinematics, specifically streamlines, streaklines, and pathlines. Okay, so first let's ask what are these things? And so all three of these are techniques for flow visualization, and that, they're ways for us to visualize fluid flow. And so the thing with fluid mechanics is that it's quite complex, and so if you've taken a fluid mechanics class, you probably know that already. And so just visualizing what's going on inside a fluid flow is not a trivial matter. And so we have different techniques that are out there to help us see, what's going on in a fluid flow. And the three main ones that we'll be going over are streamlines, streaklines, and pathlines. And so although these three techniques are similar, and in fact, I think they get confused for each other quite a lot, there are subtle differences in how they are defined, which are going to be going over now. Okay, so first let's talk about streamlines. And so the definition for streamlines is that they are the family of curves that are instantaneously tangent to the velocity vectors in an instant of time. And so the way I like to think about streamlines is that they're like taking a snapshot of the current state of a flow field. And so kind of the keywords here are instantaneously and snapshot. And so it's like you have a fluid flow and you're taking just a picture of it, of what it's how it's going at this instant of time. Okay, and so mathematically we can define the streamlines as the following function. And so we have dy dx is equal to u over v, where dy dx here is the slope of the streamline, and so think of that as a normal xy curve. U and v here are the x and y components of the velocity. And so what this equation shows us is that the streamline is everywhere tangent to the velocity vectors at that instant in time. Okay, so next we have streaklines, and so streaklines are interesting. And so the definition for streaklines is that they show all the particles in a flow that have passed through a certain point. Okay, and so the way you can physically imagine this is that it's like injecting dye into the flow and then watching how that dye distributes with time. And so I think this animation that I have here does a good job of showing that as well. Right? And so mathematically, the definition is given by the differential equation there. Okay, and so here we have parametric definitions for the the streakline path, as well as the velocity. Right? All right, so finally we have pathlines, and so pathlines show the trajectory of a fluid particle that they follow as they flow through the flow field. Okay. And so I think the two that get confused the most are streamlines and pathlines. And so the difference between the two is that, think of streamlines as a picture where pathlines are as a video. So pathlines really follow the trajectory of a fluid particle path. Okay. And so the way you can physically think about it is you put a particle into the flow and then you just kind of watch it flow throughout the field as it goes. Okay. And so, but this process takes time because, it takes time for a particle to go through the flow. And mathematically it has that definition there on the left. Okay, so let's talk about some more about the differences. And so first let me say that when a fluid flow is steady, in other words, the fluid speed and the directions do not change with time, then all three, streamlines, streaklines, and pathlines, all coincide with each other, and there's no difference at all. Okay, so for steady flow, it doesn't matter which technique you pick, you're going to get the same visual. Okay, so where you do see differences are when the flow is unsteady. And so here are some important nodes to highlight. And so when a flow is unsteady, even when a flow is unsteady, it's impossible for streamlines to cross over each other. And so you'll never see two streamlines kind of intersect like that. Okay? Because in order for that to happen, if you have a single point in space, then there needs to be two velocity vectors coming out from there. And so the fluid has to be going two directions at the same time, which is not possible, at least not to my knowledge here on Earth. Okay. But because streaklines and pathlines they kind of develop over the course of time, it is possible for these to intersect, because if the velocity field is changing directions from one point to another, then two different pathlines or streaklines are possible to intersect over each other. Okay, and again, the main difference between these is that streamlines are just a snapshot in time. They're just an instantaneous, what does the flow field look like here? Whereas streaklines and pathlines take time to develop. And so you can think of the difference as being a picture versus a movie.